According to the International Energy Agency, for the year 2016, the global emissions of carbon dioxide were 32.1 gigatons. That's gigatons with a G. The United States produces 6,511 million metric tons of carbon dioxide, ranking as the second largest contributor, 15% of the total emissions. The main source of CO2 emissions are petroleum and other liquid fuels, followed by natural gas and coal. This fire hose of CO2 emissions has an extremely detrimental effect on the environment. Other renewable energy sources are increasing, but the demand is not being met. The primary source of CO2 emissions in the United States comes from the transportation sector. With less than 5% of the world's population, it is home to 1/5 of the world's automobiles. 97% of all cars are purely gasoline powered. This means that 28.5% of CO2 emissions comes from moving people and goods from one place to another. This dependency on petroleum-based fuels is a problem. Electric-powered vehicles are one alternative to petroleum-based vehicles. The goal is to use electric-powered vehicles and increase their efficiency. One method is to use regenerative braking. Regenerative braking is the process used to brake or decelerate a vehicle. The traditional mechanical motor uses energy to spin the wheel and uses mechanical brakes to dissipate the energy in the form of heat in order to decelerate or bring the vehicle to a halt. Electric-powered vehicles can reverse the process and make the motors work like generators to reproduce the energy that was initially applied and capture it back into the battery. Another method that I will explore is electronic limited slip differential. ELSD is a process used to determine the optimal torque that needs to be delivered to a pair of wheels. When a car is going around a corner, all wheels travel along a different path. Wheels need to communicate with each other to determine the speed each of them need to travel at to prevent wear on the tires. In this case, ELSD allows easy maneuverability. In the process of wheel spin, which occurs on slippery surfaces such as icy roads, ELSD is engaged to deliver maximum traction, which limits the speed difference between a pair of wheels. In result, ELSD improves the mobility and handling, which increases performance and driving behavior, such as oversteer or loss of traction, by delivering maximum traction. Therefore, my goal is to implement regenerative braking and electronic limited slip differential to improve and increase the efficiency and driving behavior of electric-powered vehicles. So the question is any of this new? There exist companies like Tesla Motors which produce fully electric vehicles. Other major vehicle manufacturers have taken interest in this technology. For example, Toyota pioneered the popular hybrid, the Prius, which implements battery-powered electric motor and a combustion engine that can work together or in isolation. BMW has also joined the team. They added a battery system. This battery system is only engaged when the car is coasting, braking, or decelerating, so that mechanical brakes would be used as little as possible. Overall, all these methods result in better fuel economy. So, what am I doing with this technology? I am designing a battery-powered longboard that meets the following performance and energy specs. For the performance, the board should reach a maximum speed of 32 miles an hour and should have a range of at least 12 miles. For energy, it must have a regenerative braking rate above 97%. This has been David Koval, and thanks for watching.